Hello, my name is Dr. Ali Asghar Fakhri Damashkiya. I have a PhD in epidemiology and I've recently graduated from the Faculty of Veterinary Medicine, University of Tehran, Iran. In this session regarding the Jointpoint regression, we are going to discuss model errors. But first, we need to know what errors are. For the purposes of this presentation, we define error as the difference between the fitted value and the actual value for the observation. And if we calculate the error for each observation, then square them and finally sum them, we will have what is called sum of squares or sum of errors squared, which will come up in later videos. In this slide, as you can see in the top chart, we have fitted a regular linear regression line. Each red square is the observed value. And as you can see, between the observed values and the line, there is a difference for each data. In the bottom chart, as you can see, we have fitted a Jointpoint regression and we can see the errors there too. In regression formulas, we usually show errors with an error term. Here we have xt and sometimes we could show it with epsilon. Errors usually are a process with some covariance function. In ordinary least squares, the assumption is that xt is white Gaussian noise and the covariance for st equals 0 and covariance of tt equals variance independent of t. And if this is not the case, we usually use least squares. To dive deeper into the differences between least squares and weighted least squares, we should know that in least squares, the required estimate is that which minimizes the sum of differences squared, and this estimate is the one that is optimal by the least squares criterion. However, when the variances of the observations are not constant, it is appropriate to weight observations differently. For this, we use the weight inverse 1 divided by the error of the observation. With the weighted least squares approach, the observations that have large variances will get higher weights and therefore be less influential on the model, while the observations with the small variances will have higher impacts on the model. For error correlation structure, we have three options. We choose uncorrelated when we want the program to assume the random errors in the regression model are uncorrelated. The option first order autocorrelated estimated from the data, if chosen, will tell the program that the autocorrelation parameter is to be estimated separately for each bigroup, that is, each state of the covariate. The autocorrelation parameter is estimated from the model with the default maximum number of join points or the maximum number of join points set by a user, so we have to be careful on the number of maximum join points allowed. This option works for both positive and negative correlation of errors. The option first order autocorrelated with correlation equals is to insert the autocorrelation value, which is between -1 and +1, of course. This represents the correlation between adjacent points. In Jointpoint trend analysis software, as you can see after loading the data, we can come to this box, heteroscedastic or correlated errors option. Here I can choose to have constant variance option, or if my errors are uncorrelated but are not constant, I can choose the standard error calculated or Poisson variance. Poisson variance only works for crude rate and count data. In this dataset I'm using crude rate, so I can choose this option or choose constant variance or standard errors calculated, since I'm using the dataset to calculate the crude rate. This option is not available for pre-calculated crude rates. For this example, I'm choosing constant variance. In the box below, I can choose the error model. I can assume uncorrelated or first order autocorrelation estimated from the data. In this option, software will calculate the autocorrelation for me, or choose first order autocorrelation with correlation equals provided, where I can type then autocorrelation. For instance, in this example, I'm choosing 10% autocorrelation. Thank you for your attention. If you like content like this, don't forget to like and subscribe. I have created a playlist of videos similar to this one that you may like to check out. Thank you for your time.